Well, hello everybody. Here's what I need to teach you today. We are currently in Chapter 3, so I need to teach you Chapter 3, Day 2. Last time we did solving systems by graphing. If you're currently watching this video, that means you've already taken your homework quiz. Hopefully you did well on that. And then I'll cover systems with you which is called the elimination method or the addition method. If you're watching this video because you missed, then you also missed a homework quiz, and we need to get you in ASAP and get that taken. But if you would, guys, come over to your number 1 here. Last time we solved these by graphing. Graphing's nice if, when you solve for y, you get nice numbers, and if all the numbers fit on your grid. That's not always the case. In this case, if you try to solve these for y, you're going to get some ugly numbers. So graphing's not a very good method. What I'm going to show you today is what I call the addition method. The addition method is sometimes called the elimination method. And what it means is when you add your equations, you want a variable to drop out. And it does not matter if it's x or y. So I'm going to show you what I call 3 different types today. Here comes my type 1. In type 1, when you add those 2 equations together, something's going to drop out right off the bat. Well, check out what happens when you add negative 3x and positive 3x. Those come out to be 0. So I'm going to ignore those for a second. Those cancel out. I've got 7y plus 4y is going to be 11y equal negative 1 plus negative 10. Notice we're adding is negative 11. I'm going to get a y value of negative 1 after I divide both sides by 11. Well, remember last time when we graphed, all of your answers were in ordered pair. Well, right now I know the y value is negative 1. I need to go get the x value. So, to get the x value, you pick whichever equation you want to work with. The first one or the second one, it does not matter. But you plug your y value in place of y. So in this case, I'm going to plug it into the bottom. If I plug it into the bottom, here's what I got now. I have 3x plus 4 times negative 1 equal negative 10. Now let's solve that. I've got 3x minus 4 equal negative 10. Add 4 to both sides and get negative 6. Divide both sides by 3, and we're going to get an x value of negative 2. So there's my solution. Once again, guys, don't miss these because they're so easy. I'm going to switch colors here on you, maybe. Guess not. I'm going to plug in a negative 2 wherever I see an x and a negative 1 wherever I see a y and see if I get a true statement. Negative 3 times negative 2 is 6. Positive 7 times negative 1 is minus 7. If I go 6 minus 7, notice I get negative 1. So we're off to a great start. Let's check the second equation. I'm going to go 3 times negative 2 and get negative 6. Positive 4 times negative 1 is minus 4. Negative 6 minus 4 is negative 10. I know this is the correct solution. So then we have it. So that's what I call my type 1. When you add together, something's going to drop out. If you look at your type 2 there, number 2 I meant, notice that the same thing happens. If I add these together, my x terms are going to drop out. I'm going to be left with negative 5 plus 2, so I've got negative 3y equal negative 1 plus negative 8 is negative 9. Divide both sides by negative 3 and get 3. So I know my y-coordinate is 3. Let's use that to get my x-coordinate. So plug it into whichever equation you want, the top or the bottom. I'm going to plug it into the bottom. The only reason being, that's positive. So I'm going to have 7x Positive 2 times 3 is positive 6 equal negative 8. Let's minus 6 from both sides and get 7x equal negative 14. Divide both sides by 7 and get negative 2. So my answer to the second one, negative 2 comma 3. And then just like we did on the first one, you could check it by plugging it in to the equations and make sure you get true statements. Now, look over at your next one, your number 3. Now notice your number 3 is just a little bit different. If I add, and you won't do this right off the bat, don't write this down, but if I add, notice I'm going to get 10x plus 4y equal 38. Nothing dropped out. So that's a bad first move. That's a bad first move. So what I'm going to do is try to make something drop out. Now guys, you got a lot of choices here. Notice that the 3 and the 7 don't have much in common, but notice the 2's almost drop out. So I'm going to multiply one of the equations by negative 1. It does not matter which one. But watch what happens when I do that. I'm going to get negative 3x minus 2y equal negative 9. The bottom equation I'm going to leave the same. 7x plus 2y equal 29. Now look what happened when you add. The y's are going to drop out. So I'm going to have negative 3x plus 7x, which is 4x, equal 20. Divide both sides by 4. And notice in this case I got an x value of 5. On the first ones, the x's dropped out and we had a y value. This time we got an x value. No big deal. To get your y value then, plug this 5 into either one of these x's. It does not matter which one. This time I'm going to use the first one just to do something different. So I'm going to plug a 5 right where the x is. So 3 times 5 is 15 plus 2 times y equal 9. We're going to minus 15 from both sides and get 2y equal negative 6. Divide both sides by 2 and get y to be negative 3. So my ordered pair this time, x was 5, y was negative 3. Guys, while I'm here, just to show you, let's pretend that you plugged it in for the second equation. I'm going to plug my x equal 5 right there. 7 times 5 is 35, plus 2 times y equal 29. Subtract 35 from both sides. So I've got 2y equal negative 6. Divide both sides by 2 and get the same answer. So the moral of that story, it doesn't matter which equation you use as long as you use one of them. Okay. On to number 4, we're going to switch it up a little bit. We're going to switch it up a little bit now. Notice that when I add, nothing drops out. Nothing at all drops out. So we're going to try to fix that to where it does. So here comes another rule for you. You get to multiply by whatever you want to either equation other than 0 so that when you add, something's going to drop out. So guys, what I'm going to do, I'm going to ask myself, can I turn a 1 into a 3 or a 3 into a 4? I look little number to big. Well, I'm going to say to myself, I can multiply this bottom equation by negative 3. The negative is important. When I distribute now, I'm going to have a negative 3 and a positive 3. Those are going to drop out. Now my suggestion to you, stay organized in your work. I'm going to come over here and rewrite the top equation that I did not change. And in the bottom equation, I'm going to distribute that negative 3. So I've got negative 3x minus 9y equal positive 3. So I took everything times negative 3 in that bottom equation. Life is good right now, guys, because these drop out. Now I'm going to go positive 4 and negative 9 make negative 5y equal negative 10. So my y value is 2. My y value is 2. Now, a suggestion. I need to figure out my x value. Come back to one of your original equations. You could use that one, or that one. But I'm going to come back to my original equation because my numbers are traditionally smaller. And you pick which one looks easiest to use. Well, to me, the bottom one looks easier to use. So I'm going to plug my 2 right there. What are you left with? X. Positive 3 times 2 is positive 6 equal negative 1. Solve that thing for x. Subtract 6 and get negative 7. My solution set, negative 7, 2. Negative 7, 2. Okay? On to my number 4. I guess in my case, my number 5. 2x minus 5y is negative 28. If you look at it, nothing's going to drop out the way it stands. So look little number to big number. Here's what I mean. Look 2 to 6 or 4 to 5. Ask yourself this. Can you turn a 2 into a 6 pretty easily? And the answer is yes. You could turn a 2 into a 6 by multiplying by 3. But pause before you do any work. If you distribute, you're going to have a positive 6x and a positive 6x. Nothing's dropping out, so we need this to be a negative 3. Let's come over here and stay organized. Let's distribute the negative 3 and get negative 6x plus 15y equal positive 84. So I just took that negative 3 times everything. The bottom equation we left alone. So 6x plus 4y equal 30. Now, when you add, something's going to drop out. The x's drop out. 15y and 4y make 19y equal 114. Divide both sides by 19 and get 6. So my y value is 6. I'm going to come back to one of my original equations and plug in y equals 6. It does not matter which one, guys. I'm going to pick the bottom. I'm going to plug 6 right there. So check out what I got. I've got 6x. Positive 4 times positive 6 is positive 24 equal 30. Subtract 24 from both sides and get 6. Divide both sides by 6 and get 1. So it looks like my number 5, x was 1, y was 6. Okay? So now, what I've done with you so far is I showed you how to handle it if you had to multiply one equation, if you had to handle it, if you had to multiply two equations. Now I'm going to show you what happens if you got to multiply both equations. So now, on to your number 6. Notice this if you would. Notice that if I add, nothing's in common. I can't turn a 2 into a 3 very easily, and I can't turn a 4 into a 7 very easily. So you got to ask yourself, what could you do maybe? So here's what we're going to do. I'm going to take my first equation, And I'm trying to switch colors here on you just so I can show you something. What I'm going to do here is I'm going to find a number that 5 and 2 have in common. 5 and 2 have a 10 in common. Well, I can turn a 5 into a 10 by multiplying by 2. That means I need to multiply the bottom by 5. Now, before we do anything, think about what you have. I'm going to have a 10x there and a 10x there. At this moment, nothing's going to cancel out. So one of them's got to be negative. It does not matter which one you want to be negative. I'm going to make the bottom one negative. Stay organized. Distribute a 2. So I've got 10x minus 6y equals 64. Distribute a negative 5, and I've got negative 10x minus 40y equal, oh boy, negative 340. Add those together. Notice that your x's drop out. Add what you have. So I've got negative 46y equal, and then add those up, and it looks like negative 276. You could use your calculator on that, make sure I'm right. Divide both sides by negative 46. It looks like my y value is going to be positive 6. Make sure you really watch your signs there. It's easy to mess up a sign, which is mess up everything. Now, I know that y is 6. Now let's go get my x value. So I'm going to ignore everything from my original. I'm going to plug a 6 right there. And when I do that, I'm going to have 2x. Positive 8 times positive 6 is 48 equals 68. Let's subtract 48 from both sides and get 2x equal 20. Divide both sides by 2 and get 10. So your solution, 10, 6. Now guys, remember, I'll say it one last time. To see if you're right, plug in this guy for x, this guy for y, and see if you get a true statement. 5 times 10 minus 3 times 6 is 32. 2 times 10 plus 8 times 6 is 48. I know we're golden. I know we're golden. So guys, there's where we are so far. Now, come over and peek at your next one. Now, on your number 8, if I was in class, I would ask you, what do you not like? And I know what your answer would be. You would say that you do not like the fractions. So, we're going to go back to chapter 1 real fast. We did this at the start of the year. I'm going to get rid of the fractions first. So, if I look at my first one here, guys, what do you got to multiply by to get rid of the fraction? And the answer is 2. My denominator is a 2. So now I'm going to multiply everything by 2. So 2 goes into 2 once, times 3 is 3, so I've got 3x, plus 2 times 2y is 4y, equal 16. So I multiplied everything through by 2 to get rid of my fractions. Now the bottom one's a little different. Notice that my biggest denominator is a 4. 2 goes into 4 also. So I'm going to multiply everything by 4. Now I can play this game. 2 goes into 4 twice, times 1, so I'm going to get 2x. 4 goes into 4 once, times 5 is 5y, equal 4 goes into 4 once, times 13 is 13. Now we're to where we were on number 6 and number 7. So you got to decide what would you like to do. So you ask yourself this: could I turn a 2 into a 3? The answer is no. Can I turn a 4 into a 5? Once again, the answer is no. So you got to find a number that 2 and 3 have in common, or a number that 4 or 5 have in common. Well, 2 and 3 have a 6 in common. So I'm going to multiply the top by 2 and the bottom by 3. Now, if I do that, look at what I got. I've got 6x there, and I got 6x there. They're not going to drop out when I add. So one of them's got to be negative. It doesn't matter which one you make, so I'm going to make this one negative. Now I'm going to come down here since I'm running out of room. When I distribute this negative 2, I've got negative 6x minus 8y equal negative 32. When I distribute my 3, I've got 6x plus 15y equal 39. Add those together. Notice that these x's drop out. I'm at 7y equals 7. So y must be 1. Now at this moment you got a ton of choices. You can come back and plug it into equation 1, equation 2, equation 3, equation 4, equation 5, equation 6. Pick the one that's easiest for you. There's no way I'm going to use fractions. So I would come back to one of these second ones that we made. The numbers are a little smaller, so I would come back to one of those. Does not matter which one. I'm going to plug y equal 1 into the bottom, and I'm going to get 2x plus 5, because 5 times 1 was 5, equal 13, minus 5 from both sides and get 8, divide both sides by 2 and get 4. Solution: x was 4, y was 1. Now guys, this one started way back with a fraction. So we multiplied through by our common denominator to get rid of the fraction. Okay? Now, I've just got a couple more I'd like to show you. I'd like to jump over to your number 10. I'm going to mention your number 9. The video's not too long, so on number 9, just to make sure you understand how to get rid of those fractions, decide what you'd like to multiply by to get rid of those fractions. On the first one, what could I multiply by to get rid of everything? Well, my only denominator is a 3, so I'm going to use a 3. Then I'm going to play this game. 3 goes into 3 once. 1 times negative 8 is negative 8x. Plus 3y equal 25. 3 went into 3 once, times 25 was 25. Now the bottom equation, the only denominator I have is a 2. Multiply everything by 2, I've got negative 4x plus 5y equal 23. So now here you go. There's your 2 new equations. Look at them and decide what's easiest for you. If we add together, nothing drops out. But ask yourself this: could you turn a 4 into an 8 or a 3 into a 5? Well guys, we could turn a 4 into an 8 kind of easily. I'm going to multiply this bottom equation by a 2 for a second. But ask yourself this: if you do that and add, will they drop out? My top is a negative 8. My bottom is a negative 8, so the answer is no. So I need to use a negative 2. If I do that, here's what I've got. I'm going to bring all my work down here. The top equation I'm going to leave the same. The bottom equation gets multiplied by negative 2, so I got positive 8x minus 10y equal negative 46. X's drop out. I've got negative 7y equal negative 21. So my y value must be 3. So once again, figure out where you would like to go plug that in and figure out your x value. So I'm going to come back up to my ones in black. I'm going to plug y equal 3 right there. If I do that, I have negative 8x plus 9 equal 25. Subtract 9 from both sides, and I got 16. X must be negative 2. So my solution, x was negative 2, y was 3. Now, my last two is only going to take a minute, guys, so hang with me. There are two special cases. They're really kind of easy once you see them. Notice that on my number 10, if I add, nothing drops out. So I'm going to ask myself, could I turn a 3 into a 6? And I could if I multiplied everything by negative 2. Now decide real fast if that needs to be negative 2 or positive 2. My top is negative 6. My bottom is positive 6, so we're good. Leave your top alone and get negative 6x plus 8y equal negative 31. The bottom becomes 6x minus 8y equal 24. Check out what happens when we add them. That's a 0 and that's a 0. So I've got 0 equal negative 7. That is a false statement. That tells you that there's no solution. It tells you that the lines are parallel. We had one of those on our assignment the other day. So on this one, there's going to be no solution. The reason that there's no solution, these lines are parallel. Now, compare that to my last one, and I'm almost done. If I add, nothing drops out. So I'm going to ask myself, can I turn a 3 into a 6? The answer is yes, by multiplying by 2. Notice that it's very similar to what I had earlier. So I've got negative 6x plus 8y equal negative 32. Distribute my 2, I've got 6x minus 8y equal 32. Check out what happens this time though, guys. That's 0, that's 0, so this side is 0. This side is also 0. 0 equals 0 is a true statement. That means there's many or infinite solutions. What that means graphically is that if we graph them, these two lines are directly on top of each other. So guys, that's what you missed the other day, or that's the lesson for the day. Good luck on your assignment. If you have any questions, come in. If you get ugly decimals, you messed up. It's okay to get a 0.5 or 0.25 or a 0.333, which is 1/3. Those are possible, but otherwise they're not. So good luck. Come in and let me know if you need any help.